Arc fault circuit interrupters, or AFCIs, have been adopted to enhance electrical safety and prevent fires caused by electrical arcs. While AFCIs are generally reliable, they can occasionally experience nuisance tripping. AFCI protection is limited to the circuit it is installed on. Line-side faults, or faults occurring outside the circuit protected by the AFCI, can cause surge currents or voltage transients that may trip the AFCI. This is because AFCIs are designed to detect arcing conditions within their circuit. If a circuit not protected by an AFCI is energized by a source that is also feeding an AFCI-protected circuit, the line-side fault on the non-AFCI circuit can cause the AFCI and the adjacent circuit to trip. This is known as sympathetic tripping. Several factors can contribute to AFCI nuisance tripping. Power line noise, specifically transient voltage spikes from power lines, can trigger AFCI tripping. Large inductive loads, such as motors and solenoids, can cause arcing during startup or operation, potentially tripping the AFCI. Dimmers and variable speed drives can generate harmonics and voltage transients that can affect AFCI operation. Loose electrical connections can create arcs that trip AFCIs. Damaged or improperly installed wiring can lead to arcing and nuisance tripping. To minimize nuisance tripping, consider the following measures. Firstly, install AFCIs on critical circuits. Prioritize AFCI protection for circuits that pose a higher risk of fire, such as bedrooms and living rooms. Secondly, isolate non-essential circuits. If possible, separate circuits that are prone to arcing or nuisance tripping from AFCI-protected circuits. Thirdly, use surge protectors. Line-side surge protectors can help mitigate voltage transients and reduce nuisance tripping. Fourthly, inspect wiring regularly. Ensure that all wiring is properly installed and maintained to prevent loose connections or damaged insulation. Fifthly, consider AFCI testing equipment. Testing equipment can help identify sensitive AFCIs or circuits that may require additional troubleshooting. It is important to remember that AFCIs are designed to protect against electrical fires. If nuisance tripping is a persistent problem, consult with a qualified electrician to determine the underlying cause and implement appropriate remedies. AFCI manufacturers have been improving their technology over time to reduce nuisance tripping. AFCIs are designed to detect very small arcs, and while this sensitivity is crucial for safety, it can also lead to them tripping in response to events that aren't actually dangerous. One potential source of nuisance tripping is shared neutrals. In some older electrical systems, multiple circuits might share a single neutral wire. When these circuits are heavily loaded, the neutral wire can become overloaded, leading to voltage fluctuations and harmonic distortion that can trigger an AFCI. Another factor to consider is the type of load connected to the circuit. Certain electronic devices, such as older televisions, computers, and some types of lighting, can generate electrical noise that can interfere with the AFCI's operation. It's also worth noting that AFCIs themselves can sometimes be faulty. While this is relatively rare, it's possible for an AFCI to be overly sensitive or to have internal components that are malfunctioning. If you've ruled out other potential causes of nuisance tripping, it might be necessary to replace the AFCI to see if that resolves the problem. When troubleshooting AFCI issues, it's essential to use a systematic approach. Start by carefully examining the wiring and connections in the circuit. Look for any signs of damage, loose connections, or improper installation. If you find any problems, correct them and see if that resolves the issue. Next, try disconnecting any potentially problematic loads from the circuit. If the AFCI stops tripping when a particular device is disconnected, that device is likely the source of the problem. Consider replacing the device or moving it to a different circuit. If you're still experiencing nuisance tripping after checking the wiring and loads, it might be necessary to consult with a qualified electrician. An electrician can use specialized equipment to test the circuit and identify any underlying problems that might be causing the AFCI to trip. There are different types of AFCIs available, each designed to detect different types of arc faults. Branch circuit AFCIs, which are the most common type, protect against arc faults in the branch circuit wiring. Combination AFCIs protect against both branch circuit arc faults and series arc faults, which can occur within cords and appliances. Outlet branch circuit AFCIs, or AFCIs, provide protection at the outlet and are often used in older homes where it may not be practical to replace the branch circuit breakers. When selecting an AFCI, it's important to choose the appropriate type for the application. In general, combination AFCIs are recommended for new construction and renovations, as they provide the most comprehensive protection. However, OBC AFCIs can be a good option for older homes where it's not feasible to replace the existing wiring. The National Electrical Code, or NEC, specifies where AFCIs are required. As of the 2020 NEC, AFCIs are required in almost all 120-volt single-phase, 15-amp and 20-amp circuits supplying outlets or devices installed in dwelling units. This includes bedrooms, living rooms, dining rooms, kitchens, and other areas where people are likely to be present. The NEC also requires AFCIs in certain other locations, such as dormitories and assisted living facilities. When installing AFCIs, it's important to follow the manufacturer's instructions carefully. AFCIs should be installed by a qualified electrician to ensure that they are properly wired and grounded. It's also important to test the AFCI after installation to verify that it's working correctly. To test an AFCI, simply press the test button on the device. The AFCI should trip, cutting off power to the circuit. If the AFCI doesn't trip, it's not working correctly and should be replaced. AFCIs are an important safety device that can help prevent electrical fires. While they can sometimes experience nuisance tripping, the benefits of AFCI protection far outweigh the drawbacks. By understanding the causes of nuisance tripping and taking steps to mitigate them, you can help ensure that your electrical system is safe and reliable. In addition to the factors already mentioned, there are a few other things that can contribute to AFCI nuisance tripping. One is the presence of ground faults in the circuit. A ground fault occurs when current flows from a live wire to ground, which can happen if the wire is damaged or if there's a short circuit. AFCIs are designed to detect ground faults, and they will trip if they detect a ground fault above a certain threshold. Another potential cause of nuisance tripping is the use of extension cords. Extension cords can be a source of arc faults, especially if they're damaged or overloaded. If you're using extension cords on a circuit protected by an AFCI, make sure they're in good condition and that they're not overloaded. Another thing to keep in mind is that AFCIs can be affected by electromagnetic interference, or EMI. EMI can be generated by a variety of sources, including radio transmitters, cell phones, and microwave ovens. If you're experiencing nuisance tripping and you suspect that EMI might be the cause, try moving the AFCI away from any potential sources of EMI. It's also worth noting that AFCIs can sometimes be incompatible with certain types of lighting. For example, some types of LED lighting can generate harmonics that can interfere with the AFCI's operation. If you're using LED lighting on a circuit protected by an AFCI, make sure the lighting is compatible with the AFCI. When troubleshooting AFCI issues, it's important to have a good understanding of how AFCIs work and what can cause them to trip. It's also important to have the right tools and equipment, such as a multimeter and a circuit tracer. A multimeter can be used to measure voltage, current, and resistance, which can help you identify problems in the circuit. A circuit tracer can be used to trace the path of the wiring, which can be helpful if you're trying to locate a ground fault or a short circuit. If you're not comfortable working with electricity, it's always best to consult with a qualified electrician. An electrician can diagnose the problem and make the necessary repairs safely and efficiently. AFCIs are an important part of a comprehensive electrical safety plan. By installing AFCIs in your home or business, you can help protect yourself and your family from the dangers of electrical fires. While AFCIs can sometimes experience nuisance tripping, the benefits of AFCI protection far outweigh the drawbacks. By understanding the causes of nuisance tripping and taking steps to mitigate them, you can help ensure that your electrical system is safe and reliable. Let's discuss the technical specifics of AFCIs in more detail. An AFCI is essentially a specialized type of circuit breaker that is designed to detect arc faults, which are dangerous electrical discharges that can cause fires. Unlike a standard circuit breaker, which is designed to protect against overloads and short circuits, an AFCI is designed to detect the unique characteristics of arc faults. Arc faults are characterized by erratic, high-frequency current fluctuations that are different from the smooth, consistent current flow of a normal circuit. AFCI's use sophisticated electronic circuitry to analyze the current waveform and detect these fluctuations. When an arc fault is detected, the AFCI trips, cutting off power to the circuit and preventing a fire. There are two main types of arc faults: series arc faults and parallel arc faults. A series arc fault occurs when there is a break in a single wire, such as a frayed or damaged cord. A parallel arc fault occurs when there is a short circuit between two wires, such as when insulation is damaged and the wires come into contact. AFCIs are designed to detect both types of arc faults. To detect series arc faults, AFCIs look for rapid changes in the current waveform. When a series arc fault occurs, the current flow is interrupted momentarily, creating a sharp dip in the waveform. The AFCI detects this dip and trips the circuit. To detect parallel arc faults, AFCIs look for high-frequency noise in the current waveform. Parallel arc faults generate a significant amount of electrical noise, which the AFCI detects and uses to trip the circuit. AFCIs also incorporate ground fault protection. Ground fault protection is designed to detect current leakage to ground, which can be a sign of a damaged wire or faulty appliance. When a ground fault is detected, the AFCI trips, preventing electric shock and reducing the risk of fire. The tripping threshold for ground fault protection is typically very low, around 5 mA. This means that even a small amount of current leakage can cause the AFCI to trip. AFCIs are required by the National Electrical Code, or NEC, in many areas of the home, including bedrooms, living rooms, and dining rooms. The NEC requires AFCIs to protect 120-volt single-phase, 15 amp and 20 amp circuits that supply outlets and devices in these areas. The purpose of this requirement is to reduce the risk of electrical fires, which are a leading cause of property damage and injury. When installing AFCIs, it is important to follow the manufacturer's instructions carefully. AFCIs must be installed by a qualified electrician to ensure that they are properly wired and grounded. It is also important to test the AFCI after installation to verify that it is working correctly. To test an AFCI, simply press the test button on the device. The AFCI should trip, cutting off power to the circuit. If the AFCI does not trip, it is not working correctly and should be replaced. AFCIs are an important safety device that can help prevent electrical fires. While they can sometimes experience nuisance tripping, the benefits of AFCI protection far outweigh the drawbacks. By understanding how AFCIs work and taking steps to mitigate nuisance tripping, you can help ensure that your home is safe from electrical hazards. Nuisance tripping of AFCIs can be a frustrating problem, but it is important to remember that AFCIs are designed to protect against electrical fires. When an AFCI trips, it is indicating that there is a potential problem in the circuit. Instead of simply resetting the AFCI and ignoring the problem, it is important to investigate the cause of the tripping and take steps to correct it. One common cause of nuisance tripping is loose connections. Loose connections can create arcs, which can trip the AFCI. To check for loose connections, turn off the power to the circuit and carefully inspect all of the wiring connections at the outlets, switches, and light fixtures. Make sure that all of the connections are tight and secure. Another common cause of nuisance tripping is damaged wiring. Damaged wiring can also create arcs, which can trip the AFCI. To check for damaged wiring, turn off the power to the circuit and carefully inspect all of the wiring for signs of damage, such as frayed insulation or exposed conductors. If you find any damaged wiring, it should be replaced by a qualified electrician. Overloaded circuits can also cause AFCIs to trip. An overloaded circuit is a circuit that is drawing more current than it is designed to handle. This can happen if you are using too many appliances or devices in the same circuit. To avoid overloading circuits, try to distribute your electrical load evenly across multiple circuits. Another potential cause of nuisance tripping is electronic noise. Electronic noise can be generated by certain types of electronic devices, such as computers, televisions, and fluorescent lights. This noise can interfere with the operation of the AFCI and cause it to trip. To reduce electronic noise, try using surge protectors and line filters on your electronic devices. If you have tried all of these steps and you are still experiencing nuisance tripping, it is possible that the AFCI itself is faulty. In this case, the AFCI should be replaced by a qualified electrician. In addition to these common causes of nuisance tripping, there are also some less common causes that may be more difficult to diagnose. One such cause is harmonic distortion. Harmonic distortion is a type of electrical noise that is caused by nonlinear loads such as electronic ballasts and variable frequency drives. Harmonic distortion can interfere with the operation of the AFCI and cause it to trip. To reduce harmonic distortion, try using harmonic filters on your nonlinear loads. Another less common cause of nuisance tripping is ground loops. Ground loops are caused by multiple ground paths in a circuit. These multiple ground paths can create circulating currents that can interfere with the operation of the AFCI and cause it to trip. To eliminate ground loops, ensure that there is only one ground path in the circuit. This can be achieved by using isolated ground receptacles and by ensuring that all of the metal parts of the electrical system are properly bonded together. In some cases, nuisance tripping may be caused by a combination of factors. For example, a loose connection may be combined with electronic noise or harmonic distortion to cause the AFCI to trip. In these cases, it may be necessary to address multiple issues in order to resolve the problem. When troubleshooting AFCI issues, it is important to have a systematic approach. Start by checking the most common causes of nuisance tripping, such as loose connections and damaged wiring. If you are unable to identify the cause of the tripping, it may be necessary to consult with a qualified electrician. An electrician can use specialized equipment to test the circuit and identify any underlying problems that may be causing the AFCI to trip. AFCIs are an important safety device that can help prevent electrical fires. While they can sometimes experience nuisance tripping, the benefits of AFCI protection far outweigh the drawbacks. By understanding the causes of nuisance tripping and taking steps to mitigate them, you can help ensure that your home is safe from electrical hazards. Remember that electrical work can be dangerous. If you are not comfortable working with electricity, it is always best to consult with a qualified electrician.